yeah, I primarily focus on UI frameworks. So today we are going to talk about how to create your own UI framework with PureScript, right? So this basically what I'm aiming to take you through today is why would you want to make a pure UI framework? That is one. Uh, because the market is very, very abundant with UI frameworks today. Second is how do you make a UI framework, and what decisions did Juspay take while we were making our UI framework? Maybe guiding you guys along that lines, right? So yeah, maybe let's just get started. So yeah, why should you build your own UI framework? And this is an interesting question, right? This is not something you would regularly do. If you're writing front end, you would rather just go with one of the existing solutions. But building your own UI framework gives a lot of merits. Mainly, first is you get to control how your code looks. Now, for example, let's say you take something like React or Cordova, then the UI framework actually controls how the rest of your code looks as well. And you structure your normal code around the framework. Whereas if you build your own framework, you get this added benefit that, hey, you can structure your UI around the rest of your code, or basically you can create your own domain specific language, and your UI can be structured around how your code or how your flow is supposed to be. Second is, at Juspay, we needed a cross-platform solution because we are present everywhere. We primarily focus on apps, maybe Android, iOS, and on web, right? So we needed one solution where we could write one code and be available on all platforms. And finally, yeah, we also need to be able to gel in with any app that we are present in. So for example, if you have an ad card form, then it's required to be able to draw that in between another apps page, in between another apps payment page. So we need the power to not disrupt another app's general ecosystem while just going through. So yeah, now coming to why would I not use something that's already available, right? So from what we said before, I think apart from the DSL part, maybe a solution like React Native or Flutter would also provide a cross-platform. Like that part of the problem is solved. Like it's solved by a lot of frameworks available today. But yeah, so I want to take you guys through three primary points of why we would want to build our own. First is size. Both React Native, Flutter, I think most of these libraries come with basically they come with a set of classes, a set of mechanisms, how they draw UI on other platforms. And they do not actually rely on the available setups. Maybe, for example, if you take React Native uses a React Native activity, whereas Android in itself has a fragment activity and it has its own lifecycle. And React Native, in order to achieve what like the exact syntax that they need, have completely overridden the existing lifecycle, right? So when you do something like that, then you have to have a lot of boilerplate that's added inside the base app. This is the first issue. Whereas if you write your own framework, you have this freedom to say, hey, I'll leverage whatever is available natively. And I don't really need to care about what is present in the, I don't really need to care about how much boilerplate a library is adding or how much boilerplate something else is adding, right? Because frameworks are meant to be generic so that these boilerplates tend to have more code than you need. Second is the environment. So okay, this is also similar to what I said in size. The catch over here is, let's say you use something like React Native, right? And or something like Flutter. So React Native provides its own choreographer. A choreographer is in Android responsible to find out what is the size of each layout or what is the size of each div. So if you are, let's say, and I brought up this use case where I'd like to draw UI in between another app's UI, right? So let's say I want to have one choreographer to draw one half of my UI and another choreographer to draw another half of my UI. Then I'd actually need to control this behavior. If you write your own framework, you will be able to do this. But if you use an existing framework, then you will have to go modify the code and eventually deviate from the framework itself. Moreover, to say you wrote your own framework, right? Or if you take Flutter for this matter, right? Flutter uses a canvas. It doesn't even use the choreographer as a concept. It basically draws everything as a diagram rather than drawing everything as layouts as traditional frameworks do. This in itself is very difficult to fit inside another app or inside another framework. Let's say two frameworks gelling in together itself is difficult unless you have more control. And finally, reliability. Now let's assume in the odd case that these frameworks get an issue, right? What your general principle would be is you would go, one, you would walk around the issue. Second, you would raise an issue to the framework developer. And uh, yeah, and finally, once you do both of these, right, you have this case where, yeah, you're not able to solve the issue in time, and that can lead to you losing business to something of that extent, right? And this is not something usually in a company you are able to afford. So, okay, when you have your own framework, you have that freedom to go and fix anything at any point. And you also have that freedom to not lose time, which I think in a third-party framework, you are kind of lacking. Right? Going ahead to maybe now let's actually go ahead to the core of what a UI framework is. A UI framework in general is, maybe I can say, just 3 steps. One, you have to draw a UI, which is the obvious. You need some way to actually just present your UI, right? Second is you need some mechanism to receive events. So this, I mean, as simple as it sounds, you might actually want maybe 1 channel or 2 channels where events come in to a single collected point than them just being haywire. And third is you need a mechanism to update your UI when you get an event. And yeah, and all of these 3 are very, very tightly linked. Yeah, apart from this, yeah, we'll also need to say, okay, how, like I said before, you'd like to have a DSL which fits a lot with your own coding pattern. I think with Juspay, we chose the Elm architecture because it allows you to declaratively write code. And that allows this one core feature where you can always come back to the same place where you dropped off. So let's say you have a data block of 5 keys. If you take the same 5 keys and come back and start your UI at any point, you can restore your UI back to exactly what it is. And I think that is why we chose the Elm architecture. Maybe I'll just go in a bit of depth on the Elm architecture as well. So the Elm architecture again has 3 main parts. Just like how we said before, we had 3 main parts for what a UI framework is. If you look closely at this, these 3 parts are also similar. But the primary difference is, one, Elm architecture has a model. A model is, maybe you can say, just data, right? So you need to have a mechanism to represent your data. And this is like how you have maybe a data, how do I put it? You have this SQL, right? Where you have a table or a data schema. And this model is similar to that data schema in your MVC. Then you have a view. The view is how your data is represented to your user as an interface. And finally, again, you have the mechanism to update. On any event, you need to be able to update the model, and the model is what reflects into the view. So this is the declarative method that I was saying, where you can say, hey, I've declared ahead of time what my UI is going to be. And at this point, you can come down and say, okay, now that I know what my UI is going to be, if I update my model, the UI is going to follow it, right? Yeah. Now that we know, okay, we know what we want and we know how we want to get there, like what architecture to use to get there. Yeah, so we primarily chose 2 existing PureScript libraries to achieve this. One is PureScript Halogen VDOM, which is basically a library which allows to have a virtual DOM and the virtual DOM diffing. Second is PureScript Behaviors. Behaviors is a very nice concept where basically it uses functional reactive programming and allows you to have a different type of event stream. Maybe I'll actually get into more details to explain how this works a bit ahead. But yeah, maybe first we'll start with the virtual DOM. So yeah, what is a virtual DOM and why do we need it, right? So generally, whatever you see on your screen, like if I take a HTML page, whatever you see on your screen, this is the DOM. And any manipulation or any visualization into the DOM is a heavy operation because it is an IO operation. Let's say I just want to get the height from a DOM, that is also an IO operation, and it actually takes more time than your traditional record read, right? So to avoid this time, we generally come up saying, hey, I need a virtual DOM. Basically, I need a representation of something that is exactly the same as what is drawn on my end as well. So I can say, okay, I have a real DOM, maybe of height 20, width 20. And I'll also have a JSON, which is saying, okay, property is height 20, width 20. So now when I need to do any comparison operations or any actual, let's say any large number of operations, then I don't really need to operate on the UI thread or the IO thread. I can actually operate on the general JS worker thread. And this allows me to be much faster. So this is the primary use case of why we would need a DOM. And yeah, so I think here I have a type explaining what the general structure of a DOM tree would be, right? Maybe in any UI tree, if you look at it, is saying you have one guy saying, okay, what type of UI is it? Maybe in case of your HTML, you can say it's a div or a span. In case of Android, you can say it's a linear layout, and so on. Then you have a set of properties that define how the UI looks. So a div in itself says nothing, but if I say the div is of height 20, width 20, let's say background red, and so on, you can actually define a proper look for the div. And finally, you have an array of children. An array of children is basically just how you extend the tree and say, this current element can have a similar type of elements as its children. I think this is very like maybe I could say that this is the standard structure, and most of you would have come across this at some point in time, right? Yeah. So now that we know what a VDOM is, maybe I'll just go into some depth of what Halogen VDOM is and what does Halogen VDOM provide, right? And why would we need it? So Halogen VDOM is a framework which is primarily used as it's a framework to build frameworks. That's the best way to put it, right? And Halogen VDOM has been built with a name of how to use as little FFI as possible and how to get your code patching as quick as possible. This have been their two optimization points. And yeah, now coming into their implementation side, they have maybe just three major things that they do everywhere. One is build, second is patch, and third is halt. And as the name suggests itself, right? Build is used to create a node in a VDOM. So basically, if you go back to the previous slide, you can see this is the representation of a node. What build is responsible to do is it is responsible to create this structure. It is also responsible to actually draw that node on your UI. So this is one. Second is patch. Now let's say you have an update on the node, right? Let's say one of your props height changed to 2. So what Halogen does is it is going to compare your existing DOM with the current DOM. And it will find out that, hey, only height has changed. And it is going to trigger just a patch operation or just a lightweight operation to update that one property. And this is patch. Finally, we have halt. Halt, as it's like, I mean, the obvious next step is we need a mechanism to remove something we built or something that is no longer needed. Let's say I remove the height property, then I need to trigger a halt on the height property to remove it. Similarly, I can say I can remove one node completely from the tree, and I need a halt property to completely delete a node. So when you check your VDOM, then this is actually where it stands. So you have a build, you have a patch, and you have a halt, and all three of these constructs apply on both the VDOM node itself and the property node as well. So you have three core constructs which apply in two places: your build, your VDOM node, and your property tree, right? Finally, yeah, maybe so now I think that is a reasonable understanding of Halogen. I don't think we need to go much more into depth than this. Like I said ahead, we have two core things that we use. One is the VDOM, second is functional reactive programming. Maybe yeah, so this is a very interesting thing that you guys can actually read about. What functional reactive programming does is it allows you to treat values. So let's say you have a model right now, right? It allows you to treat that model instead of being a value or instead of being just one value in time. It allows you to treat it as a continuous function over time. So now that you're in a functional programming environment, you have this capability to say functions are first-class citizens. So when you have functions as first-class citizens, we can say that instead of saying, okay, state is equal to one JSON, I'll say state is equal to a function of a JSON. And this function is only going to come in when it so this function is only going to be used when someone does a sample. So basically, you can say that you have a graph. You have a graph of values, which is either across time or across any event stream for that matter. So one side is the current value and the other side is the event stream. And at this point, you can actually go and so basically you can keep updating this graph at any point. You know this does not necessarily need to reflect your, so you have a model and it does not necessarily need to reflect your view. Then you will also go and sample this graph at maybe for using another event stream. And whenever you sample that graph, you will get that is the point you will update your UI. This is the basic understanding of functional reactive programming. I think there are two FRP models available today. One is continuous, second is discrete. Continuous is when you sample at a fixed rate. Maybe you sample across time and you update it as and when you go, right? But in a general UI interface, continuous does not really make sense because you do not want to update on a fixed rate. That's more in the terms of something like a video. A video would be updated at a fixed point, or an animation would be updated at a fixed rate. But something a UI interface gets updated more in the lines of at every user interaction, right? At every user event. So in our case, we are going to go for the discrete model. So discrete model is where the sampling is done at a discrete point in time, right? At a discrete event. This is where PureScript behaviors come in. PureScript behaviors is a library strictly modeled after FRP. So I don't think it actually needs an additional explanation, but let's actually jump to some code. Yeah, so while jumping to code, maybe I just want to quickly run you guys through some. Okay, okay. What you guys are looking at right now is halogen VDOM, and halogen VDOM, like I said before, has two representations. One is for the DOM tree. So if I'll just take you back to that slide. So now you have one as this DOM tree, which is represented by this VDOM type. Here you can see LM. LM has an LM name and an array of VDOM. This array of VDOM is going to be your children. Similarly, this guy is also, basically, this is a structure which is going to maintain what you have here: a type, a set of props, and a set of children. Second is you have the set of props, which is represented either as an attribute or property. So again, in a standard world, right? Let's say if you're using HTML, you have two types of props or multiple types of props. One is something like inner HTML, which you directly apply to your element. Second is something like height, which you apply to the element.style. So property is something that you'll directly apply to your element. Similarly, attribute is something that you will apply to a namespace, which is style. And finally, handler is a representation of, what is that? Handler is a representation of functions. So you can say if you have an on click, then you don't really need the type to come in as a string. You need the type to come in as a function, and handler is a representation of that. So that's a quick brief on halogen itself. So now let's just go and maybe get started on creating the UI framework, right? So just to recap, what does the framework need? One, we are following Elm architecture, so we need to create a model. Then we need to create a view based on the model, and finally we need a function to update. Hope everyone is following. So keeping this in mind, I'll just take you to a sample that I've written. Just have one second. Just have this on both sides. Yeah. So now you can see that we actually have something called a create screen, which is taking a view, your state, which is your model. So you can say that your state is the model, and finally you have an update, and this update is responsible to change the state whenever any event happens, right? Okay, so we're looking like this is very straightforward. So you have a view, update state, like as we mentioned. Now let's maybe I'll just walk you guys through also what we need from both the other libraries that we talked about. First is behavior. So when we talk about behaviors, right? So now we have a value. So you have your state, which is of maybe type data gives, which is of type count int. And you want to create an event stream. Now you want to create a behavior and of the type count, right? Okay, so your aim, I mean, maybe the final aim of what we're going to do is to have a behavior of type state. Now to achieve that, what we need is first we need to create an event stream. This event stream is what, am I audible?
Yes, sure.
Yes, sure. The video got stuck, so I had it out. Yeah, sure. So like I mentioned before, the behavior is a function of an event stream, right? So first we are going to create an event stream for which it should become a function of. Second is we have to tie that event stream with the current model to form a behavior of the state. Third is we need to sample that behavior, that event stream against the user interaction events. So basically we need to, let's say we are creating a dummy event stream which has no events. We need to tie this event stream into the actual event stream, into the actual event chain. And finally, we need to send whatever we are sampling into halogen view DOM. So now taking you guys through actual code that does this, right? So just observe, we have a create screen function here, which is taking this JSON. Yeah. So if you see, we have step one, creating an event stream. Now this is again an available interface in PureScript behavior. This gives you two things. One is push. Second is an event stream. Push is a function that basically fires an event into the current event stream. Second thing that we need to see is you need to create a behavior using the event stream. So we have a function called unfold, which basically does number 2 and number 4. What it does here is it takes the current model, it takes your event stream, and it creates a function which is tied to your model and your event stream, and it registers this update as the function to be called whenever your model is updated. And basically this update is a screen give screen function. So the idea is whenever an event is fired, it updates the current event, a current state to the latest, to a value which is given by update. So if you go to update, you can see the type is state gives state in those lines, right? And finally, you want to sample. So you want to sample your behavior against the same event stream. So right now for us, we don't really have two event streams, one against time and one against user interaction. We're going to stick to both the event streams being the same, both tied to user interaction. So finally, you have a guy which says sample the current behavior against the user interaction stream. So you have a behavior which is created against the same stream. And whenever there's a change, it fires the update. And once the update is fired, we have subscribed to the sample. And in this subscription, what it's going to do is it is going to fire your update UI. Yeah. Before we go to update UI, maybe I'll just walk you guys through what does Halogen need as well. So Halogen first needs a spec. So the spec is basically how to draw UI. So Halogen, what it needs is it needs a mechanism. It needs you to tell it how to draw UI. So this is the spec. Second thing it needs is it needs you to provide the VDOM. So we need to provide a VDOM, which is basically it is your actual view tree itself, the view function. So it needs you to provide a VDOM, and it is going to create an intermediate state called a machine out of this VDOM. So you can say that this machine is also exactly the same as the VDOM. What is the difference? It doesn't. I mean, it's just a data transformation which saves a bit additional states. Finally, you need to remember this machine. So we are going to go ahead with a ref, and this ref is going to remember the latest value of the machine. And last, which you've already seen with behavior, you need to update the machine whenever there is a change. Maybe that is how we'll put it, right? So behavior is going to trigger an event. The event is going to update your model, and the model is going to trigger a change. So going back to your core.pers, you can see that we left off where you have a subscription to your state event, which is your behavior. And that subscription says update UI. So update UI has again 3 arguments, latest machine, as we discussed. Let's move this also to the other side. Yeah. So we have to save the latest machine. So we are sending the latest machine. We are sending the screen JSON, which is our Elm structure that we created. We are sending this push so that we can actually create the view out of the screen JSON. Maybe you can say that this push is just for type constraints. And finally, we are sending the latest value of the model. So on this current sample, whatever the value of the model is going to be sent. So I'll just take a step back and show you guys how this latest machine was created. Right? Yeah. So if you see over here, we say build VDOM. Build VDOM uses a spec. A spec is something that just takes a document. This document is so this is my sample implementation of how to draw UI. There is nothing special here. I'll just run you guys through it in the end. But this is just a straightforward mapper of drawing UI. So now that you have a document, or maybe you can say now that you have your mechanism of how to draw UI, what we're going to say is we're going to say screen.view, send it the function that can allow to push events. And finally, we send it the initial state or your base model, right? So if you go here, you can see that create screen, this is the screen value. And we are sending screen.view, which is represented here as a layout of height 100%, width 100%, text as state.count, and finally an on-click event. And we're sending that here, and we're going to construct a VDOM using that DOM tree that you saw that. And finally, it's going to make a machine. While making a machine, this sorry, I think this is lagging for some reason. Yeah. So to make a machine, yeah, like I said, we have a dummy implementation mechanism here. I'm just checking if it's of type layout and creating a div. Similarly, just a few standard web functions to go ahead and draw the UI. But so baseline is, yeah, you have a sample, right, which you can use. I mean, you can extend this mapper however you want. So when we say we are going to make it cross-platform, what we're referencing is this get document function. We are going to extend with different implementations for Android, different implementations for iOS. And here currently you can see that I've only mapped the three things that I'm using: height, width, and text. We can actually map this to any number of things we want. And if you remember, we had an attribute and property type, right? So based on what type halogen sends, you can have more generic functions. Like rather than having if height set height, you can say if your namespace is style and the value you get is height, then set its value. You can write very generic functions which automatically do the mapping for you as well. So this is just standard HTML code of how do you create, I mean, standard JavaScript code of how do you create UI. And yeah, finally, you can see that we've created a VDOM using this. Second, this is lagging. Sorry guys, I think there is some connection issues. It's lagging on my end. Yeah, just to get back. So okay, maybe I'll just run you through what is visible. So you can see that now we took the VDOM, we've built a machine, and we've saved the machine. This attached machine just takes the current element that it created and attaches it to the outer body. So if I can just run you through that function as well quickly, where you can see attach. Yeah, for some reason system is lagging a lot right now. Yeah, so you can see that all it does is it just does a document.body.append child. And finally, this guy goes to update UI. What update UI is going to do is it is going to trigger a VDOM diff using halogen VDOM on the current value of the view, which is used by the state that we receive from here. And finally, yeah, we're going to get a new machine, and this new machine internally using the document or the spec that we provided to halogen is also going to update the properties. Now, yeah, I guess, okay, I think apart from the lags, I hope most of it you guys were able to hear and understand. And so now you can see that we have everything in place. We have one layout which has height 100%, width 100%, and text which is a counter. We have an on-click function, which does an increment. And finally, we have an update, which tells the model to do the increment. Right? And I'll just show you guys quickly on what the output looks like. So if you can see, we have a counter over here, which is at 0 right now. On any click, you can see that it gets updated. And yeah, maybe as a framework user, we haven't built a very good UI, but as a framework builder, we actually have achieved how to build your own UI framework using PureScript. So I'll just maybe summarize quickly what we've discussed so far. Yeah, so now you know how to make a working framework, which maybe has a mechanism to build UI, is able to get events and update the UI using the events. And finally, yeah, this is going that based on how you create that mechanism to build UI, this can be extended to any platform. Yeah, and yeah, what have we achieved with this, right? I think this is the most important point. Can this be put to use in the real world? When you guys build your own UI framework, then you would also want to know, okay, has this been done, and what have we achieved with this? Actually been using this in production for over 4 years, and we have around 250 plus apps that use our SDK with this UI framework across all 3 platforms, Android, iOS, and web. We have over 500 million downloads, and we are processing transactions in almost all top apps in India today, right? And this is mainly possible because, one, we use PureScript, which gives us the leverage of not having to worry too much about having runtime errors or type checks, and the core advantages of functional programming itself. And the second is we have our own UI framework, which allows us the first 3 points, which I said, the reduction in size, reliability, and without changing the merchant's environment. Yeah, and I've published whatever I've shown today as code on GitHub. You guys can check it out whenever. And yeah, thanks, guys. Maybe you guys can ask any questions if you have anything. I'd like to conclude.
Thanks, George. That was a very insightful talk. And I'm especially excited to see functional programming be used on such a large scale, especially by an Indian company, and having a good experience with it. So I just had a few questions, if you don't mind talking about. So you said that you evaluated other technologies like React Native, and they did a lot more than what you wanted to do, and you build this so that you can have a tighter core and more control over the code base. So how are things like performance and maintainability of this code base? Are they also somewhere where it's better than using an existing solution?
So one thing I've noticed is, okay, so because we write code that directly reflects into Android, our performance is near similar to native Android or native iOS. For same line for native web. One thing is, yeah, I think PureScript itself has a bit of a bundle size issue. Apart from that, we don't really see any other major performance issues. But yeah, native Android also, if you overload it with a large number of views, has some issues, some performance issues. But I think that the same would apply to the same other cross-platform tools as well. So mainly on performance and maintainability. Maintainability is very easy. That is something we've noticed. Because one is we chose our DSL to align with Android, so dev docs are kind of simple to come by. Second, I think performance-wise, yeah. So maybe in places where we've overloaded our code with a lot of views, there are some hitches that we see. But in other places where we've written more simpler code, everything is extremely smooth. And I think maybe even better than React because it uses its own choreographer, which sometimes gets heavy in some particular CSS that you provide.
Wow, that's great to hear. And this was not a very large team, right? From what I recall,
yeah, we built this with a very small team at that time. Yeah, maybe like 5 to 6 people at any single point of time.
Wow, that's amazing. Yeah, are there any other questions? Does anyone want to ask any questions?
Ashwin has raised his hand. Yeah.
Actually, it's my name is Prasanna, so I'm sitting with Ashwin here. Can you guys hear me okay?
Yeah, we can hear you.
Yeah. So I have a general question. I have been kind of following, PureScript and generally Juspay's work for the last several years. And I've seen Vimal's talk about building applications as equations. Um, can you shed some light on how one might actually build apps using that paradigm? Are there any examples that you can share? What you've shared as a framework and following L model and all that is great, but if I want to build an actual application that has many screens and different navigations and things like that, how would you go about building it as mathematical equations? Yeah, I'm very, very interested in that.
Okay, so yeah, I think maybe for the factor of time, I restricted the current framework to one screen. But okay, so what we actually do on our end is we fork like you said, right? How do you do it across screens? So this one view that you see. Okay, for some reason this presentation is a bit laggy today. Okay, but main line is this: there's one create screen that you see, right? We converted this to an app, and this app basically it treats it like you can say you give an input to the screen and you get an output from the screen. So we modeled our code in a way where so the screen is considered as just one line in the code where, okay, maybe you have a payments app, right, where you say fetch the data to get, maybe fetch the payment instruments to draw, and this thing goes and does a bind. Maybe I'll just write it down where I say I'll have something like a fetch instruments, and we send this down into draw payment page, and this draw payment page actually converts into this create screen. So yeah, we've added one more layer on top of our create screen, which is maybe you can say right now I have one elm, right? And we have an internal system which has a stack of elms. So you have, instead of having one, we basically maintain another data structure somewhere which maintains a list of screens, and as you go forward or backward, it adds or pops it. Basically,
would it roughly correspond to a page in a browser, in a web app kind of situation?
Sorry, I couldn't get you.
Would you say a screen is similar to a page at that granularity, or?
Yeah, exactly. A screen is similar to a page, and so yeah. So I think the talks that you heard maybe were focused around app development, where let's say you have an onboarding flow of some kind where you have first the phone number page, then the OTP page, and then you have the home screen. So each of these, let's say the phone number page would be screen number one, your OTP page would be number two, and so on. And yeah, so finally, because the screen gives an output, we kind of have something which says handle output, which can handle so multiple cases can come out of this, right? So this guy returns a data which can be maybe a back press or maybe a proceed forward, or in certain screens like a payment page, which is much more complicated, we have maybe 10 or 15 outputs, like pay with net banking, pay with card, pay with any n number of instruments, or maybe even link your wallet and so on.
Right. Are there any examples of like a multi-page kind of a web application built using the Halogen, or that we can?
Okay, I think our last published examples are a bit old, but yeah,
actually,
I think yeah, this is something I'll actually take up, right? Maybe we'll publish more examples on how we can do this. We haven't really published a lot of examples out in the recent years.
That's exactly what I ran into when I tried it. None of it would compile, and after several attempts, I just gave up. So, is there something actually, solidly tested that we can try out? Because it sounds like a wonderful paradigm, which I really want to try, but unfortunately, I've been very unsuccessful in making it happen, even in my own development environment, forget production and all that.
Yeah, sorry about that. I think in the last few years, we kind of been focused more on internally stabilizing the product rather than, I think, yeah, from our original days, we used to be more on publishing it out. Yeah. I think this is a very valuable point. We'll also look at maybe how we can get 1 or 2 samples out, maybe how you can use this in a real world, right? Yeah, sure. I'll take this feedback. Yeah.
Can we get in touch with you directly and get some?
Yeah, sure. Sure, that should work.
Yeah, okay. I guess we could go through Anupam on the Telegram channel or something.
Sure. Yeah, sure.
Yeah, thank you.
Yeah, thanks.
All right. Are there any more questions? All right. Well, so that brings the first event in the series of events, that is FP WebConf, to an end. Thanks, George, and thanks, Juspay, for presenting this talk and presenting your work. It's been very insightful and illuminating. So the idea behind this conference has been bringing information to people about the intersection between FP and web development, and answering the question of whether an FP stack is suitable for a production web app. And I think what you guys are doing has been very, very inspirational. And I hope that it inspires more companies to adopt similar strategies and technologies. Yeah, so a word about our sponsors, the groups that have made this possible. So FP WebConf is hosted under the umbrella of JSFoo. JSFoo is one of India's earliest JavaScript communities. And it's now also a platform where you can have similar interactions with professionals around all aspects of development, including web and mobile. And they also recently launched a subscription option, which helps to organize events online and offline. And you can stay up to date on the latest happenings in the technology world. So please subscribe. If you're already a subscriber, please consider gifting a subscription to someone you would like to introduce to the community. I'm Anupam Jain. I'm the editor of this conference. I run a group called Functional Programming India, where we again hope to bring functional programming professionals in India together under one umbrella. So if you would like to have more discussions with functional programming professionals, please join. I will share the link for Functional Programming India on chat, and you can also get it from the project page. So yeah, thanks everyone for coming. If you're watching this at a later date, you can still ask questions. Either join the Functional Programming India group, or you can ask questions on the comment section on the FP WebConf page. So we'll try to get back to you after that. So thanks everyone. Thanks for attending. We look forward to seeing you on the next event as a part of FP WebConf.
Thank you.
Thank you.
Thanks, guys.